All right, so the next topic that we're going to be covering is parent functions. So when you have a parent function, we have several different types of parent functions. So the first one we're going to cover is the linear function. So with your linear function, your equation is y equal to x. Okay, your x is to the first power. And so if we're to plot some points, I'm going to start with the basic -2, -1, 0, 1, and 2. And so when you plug in -2 for x, your y value is also -2. When you plug in a -1 for x, your y value is also -1. Okay, and then so on, 0, 1, and 2. And if we graph that, our graph, these will be the points, our graph would look something like this. Okay, now I'm going to give the domain and range in interval notation. For this one, I don't think we need it, but for our domain, it's our x value. So if you see, our graph covers all the values going this way and all the values going that way. So our domain is all real numbers. Okay, so in an interval, that would be -infinity to +infinity. Okay, now next for the range. Okay, how low does our graph go? Well, we see that our graph is all the way down here, so it covers the y values all the way down here, and it continues all the way to up here, and it'll continue on for. So just like the domain is all real numbers, on a linear parent function, our range is all real numbers as well. So if we write that as an interval, it'll be -infinity to +infinity. All right, next we have our quadratic equation. So our quadratic equation is y equals x squared. Okay, so I'm going to use the same x values, -2, -1, 0, 1, and 2. So -2 squared gives us 4, -1 squared gives us 1, 0, 1, and 4. Okay, so this is what your quadratic function looks like. It's like a U shape. And it's actually called a parabola. Okay, so this is what our graph looks like. Now for our domain, if you notice, our graph will slowly spread apart. So it slowly spreads this way, and it slowly spreads in the opposite direction. So for our domain, it is going to go from -infinity to +infinity. It covers all real numbers. Okay. Now the range is a little bit different because if you notice, your graph is nowhere down here. Nowhere, nowhere, nowhere. We don't see it until we get to this point right here, which is 0, and then it goes up forever and ever. Okay. So for this one on our range, it is going to go from 0 all the way up to +infinity. Now it does include 0. If you notice here, 0 is equal to 0. So we are going to use a bracket at 0. All right, the next one, our square root function. So your square root function is actually the opposite of your quadratic function, and it is y equals the square root of x. Okay, so I'm going to be a little bit more careful with the numbers I pick. We'll start with -1, 0, 1, 4, and 9. And the reason that I'm picking these numbers is because you can take the square roots of most of these numbers. So if you try to get the square root of -1, if you do not recall from Algebra 2, you can't take the square root of a negative and get a real number. So this is not a real number. So we're just going to leave it like that. Okay. Now you can take the square root of 0, gives you 0. The square root of 1 gives you 1. The square root of 4 gives you 2. And the square root of 9 gives you 3. So if we were to graph this, this would be 0, 0, 1, 1, 4, 4, 2, and 9, 4, 5, 6, 7, 8, 9, 3. So your graph of your square root function looks like this. Okay. So now for the domain, when we're looking at the domain, if you notice, your x values are all here. So your graph does go on this side of your x-axis, but it is not on this side. There's nothing on that side of the graph. So because of this, it starts at 0. So our domain would be 0 and move all the way to infinity because it continues going in that direction. Okay, then we have the range. So the range is how low does our graph go? So if you notice, your graph does not fall under the x-axis. There's nothing down here, okay? But your graph does start at 0, And even though it's increasing very slowly, it's going to go on forever and ever and ever and ever, and it's going to keep going up and up and up. Okay, so it is going to go all the way to infinity. All right, next is your absolute value equation. So it's going to be y equals the absolute value of x. Somebody use the same as we did y equals x, so -2, -1, 0, 1, and 2. And so when we do this, I'm going to go ahead and plug -2. The absolute value of -2 is 2. The absolute value of -1 is 1. Absolute value of 0 is 0, 1, and 2. So this one is a little bit different because your graph looks like a V shape. Okay, so on this one, our domain is our x value. So if you notice, your graph does spread to the left and to the right. So our x values are going to go from -infinity all the way to positive infinity. Now for your range, if you notice, your graph it's nowhere to be found down here. It's all on the top. So it's everything above 0. So it starts at 0. Okay, on your y-axis, it starts here. And it continues to go up. So it's going to go from 0 to infinity. All right, the next one is our cubic equation. So our cubic equation is y equals x to the third power. Okay, so for this one, I am also going to be careful. We're not going to be able to pick a whole lot of numbers just because it's going to go off the graph, but you know what? Yeah, it should work. -2, -1, 0, 1, and 2. So let's see. -2 to the third power is going to give us a positive 8. -1 to the third power gives us 1, 0, 1, and 8. So we go ahead and start graphing these. -2 and 8. -1 and 1. Oh, I didn't do this right. Sorry. Like I knew there was something weird. I forgot the negatives. I'm sorry about that. So -2 to the third power would be -2 times -2 times -2, which would leave you with a -8 and a 1. Okay, so let me fix that. -2 and -8 should start down here. -1 and -1 is right here. 0, 0. Then 1, 1, and then 2 and 8. And so your graph looks something like this. Okay. And then from there, our domain, so if you notice, our graph is slowly spreading apart this way, and it's slowly spreading apart that way. So that means our domain is going to cover all real numbers or -infinity to positive infinity. All right, next, if we look at our graph, it points down forever. So it's going to go from -infinity, and it points up forever. So it's going to go up to positive infinity. All right, our cube root. So your cube root is the opposite of your cubic equation. So it's y equals the cube root of x. Okay, this is where I am going to be careful with the numbers. We can take the cube root of -8. We can take the cube root of -1. We can take the cube root of 0, 1, and 8. So I picked these numbers purposely so that we can take the cube root and get a whole number. So the cube root of -8 is -2. The cube root of -1 is -1. The cube root of 0 is 0. The cube root of 1 is 1. And the cube root of 8 is 2. So we're going to graph this. So -8, -2. -1, -1. 0, 0. 1, 1. And 8, 2. So your graph looks like this. Okay, so it's pretty close to the cubic function, but it's kind of flipped over to the other direction. So your domain, if you notice, it's pretty obvious. It spreads all the numbers to the left and to the right. So that means that your domain is going to cover all real numbers from -infinity to positive infinity. And then for the range, it's slowly moving up. So it's going to keep going up, not as fast as it would on the other one, but it is slowly going to go up. So your range is also going to cover -infinity to positive infinity. Your rational equation. So on the rational equations, this is going to be y equals 1 over x. That's what your rational equation looks like. So let's see. Let's go ahead and pick -2, -1, 0, 1, and 2. And when we plug this in, we are going to get -1/2, -1. This one's going to be undefined because if you take 1 and divide it by 0, you can't do that. You can't divide by a 0. 1 divided by 1 is 1, and 1 divided by 2 is 2. Not 2, 1/2, sorry. I stay thinking about it. 1/2. So then we graph this. We have -2, -1/2, and -1, -1. 1, 1, and then 2 and 1/2. So this graph is a little bit different because it looks like this. It avoids 0. Okay, so it comes along this way, and once it gets to 0, it shoots down. And the reason that it shoots down is because it cannot equal 0, because then that's when we have this undefined, okay? So then for your domain is going to cover all your x values. So it's going to go, it's going to go, it's going to go, but it does not cover 0. So the way that we do this is -infinity to 0. Parentheses on both because it doesn't touch 0. Then you put the little u for the union, and then it continues 0 to infinity again. Same thing for your range. It goes down to -infinity. That's where it starts. It goes up. It gets to 0, but it doesn't cover any area there. Okay? So it's going to go 0. It cannot touch 0, so it just starts back up and goes all the way to infinity. All right. Your exponential equation. So here we have y equals, and so this one's kind of different because it could be y equals 2 to the x power, 3 to the x power, 4 to the x power, but for the sake of the example, we're going to use 2 to the x power. And then from here, we're going to go ahead and take our table, and we're going to use the same numbers. So we are going to use -2, -1, 0, 1, and 2. And so 2 to the -2 is going to give us 1/4. 2 to the power of -1 is going to give us 1/2. 2 to the 0 power is 1. 2 to the first power is 2. And then 2 to the second power is 4. Let me graph it. So -2, 1/4. -1, 1/2. 0, 1. 1 and 2, and then 2 and 4. So your graph looks something like this, and it goes up this way. Okay, so your domain, if you notice, it covers all the numbers going this way, and then it continues spreading apart slowly. So it's going to be -infinity to infinity. Now your range, if you notice, it doesn't come under the x-axis, so it's going to be from 0 all the way up to infinity. And then 0, it does not cross 0. It stays right along the lines of 0. Okay, your log equation, your logarithmic equation, is the opposite of your exponential. And so for the same purpose, I'm going to use our basis 2. So log base 2 of x, that's what your y is equal to, or your equation. So I'm going to try to pick some numbers that will allow us to be able to take log base 2 of x. So we're going to put x as 1/4, 1/2, 1, 2, and 4. Okay, so log base 2 of 4 would give us 2. This would give us 1, 0, -1, and -2. So if we make our graph for this one, it would be 1/4, -2. And then we have 1/2, -1. And then we have 1, 0. And then we have 2, 1. That's not 2, 2, 1. And then we have 4, so 2, 3, 4, 2. So your log equation looks something like this. And so if you notice, it does not go to your negative x values. Your graph is nowhere here. Okay, it's kind of like this section is blocked off. So it goes from 0 to infinity. And then our range is how low our graph goes and how high it goes. So it continues to go up in both directions. So negative infinity and positive infinity. All right. The last ones, we have our sine and we have our cosine. So this one, I'm not going to touch up on it a whole lot because we're going to go over it into more detail towards the end of the year. But it's sine of x. Okay. For our x values, I don't want to confuse you guys a whole lot, but we're going to go ahead and use 0 for the middle part. And then I guess we can use pi over 2 and pi. And then here we'll use negative pi over 2 and pi. Okay, so we're going to pretend that this is half a pi and this is pi. Okay, so your sine function is going to be here at 0. It's going to go up to 1, come back down, and then okay, so this part, I just want you guys to kind of look at the pattern of what the graph actually looks like. So your sine function looks something like this, okay? It goes through the origin, and then it just kind of continues with a little wave. I can't make this perfect, but it'll look something like this. Okay, the most important part that you need to remember is that it goes through the origin, okay? The middle. So here at 0 would be 0. And then your domain is going to be, if you notice, it covers all your x values in both directions. So it'll be negative infinity to infinity. But your range, the lowest that it'll go is -1, and the highest it'll go is +1. Okay, so it does stay within these boundaries. Now your cosine is y equals cosine x. Okay, so here you would kind of pick the same numbers: 0, negative pi over 2, negative pi, pi over 2, and pi. Okay, but I don't want you guys to stress out about that. The only difference is that cosine does not go through the origin. It starts at 1. Okay, so instead of being at the origin, it'd be down here. And then it looks something like this. Okay, it looks pretty similar to your your sine function. So it looks like this, and it's like little waves going, but it does not go through your origin. It's actually symmetrical with your y-axis. So here for your domain, still same thing, it covers from negative infinity to infinity, but your range is still -1 to 1. Okay? So just make sure you know the difference between sine and cosine, because that's going to be on your delta math. Your cosine, you can cut it into 2 equal parts, okay? And then your sine function, you can't. It starts right here at 0, 0, and then makes the little wave, okay? So that's it for today. Good luck on your delta math. Let me know if you guys have any questions.